Audio Jungle. Audio Jungle.
Hello everyone! My topic for today is all about the control charts, also known as Schuhart charts, or process behavior charts. In statistical process control are tools used to determine if a manufacturing or business process is in a state of statistical control. If analysis of the control chart indicates that the process is currently under control, then no correction changes to process control parameters are needed or desired. In addition, data from the process can be used to predict the future performance of the process. If the chart indicates that the monitored process is not in control, analysis of the chart can help determine the sources of variation, as this will result in degraded process performance. A process that is stable but operating outside desired needs to be improved through a deliberate effort to understand the causes of current performance and fundamentally improve the process. The control chart is one of the 7 basic tools of the quality control. Typically, charts are used for time series data, though they can be used for data that have logical comparability. Compare samples that were taken all the same time or the performance of different individuals. However, the type of chart used to do this requires the consideration. The chart usage. If the process is in control, 99.73% of all the points will fall between the control limits. Any observation outside the limits or systematic patterns within suggest the introduction of a new and likely unanticipated source of variation, known as a special cause variation. Since increased variation means increased quality cost, a control chart, the presence of a special cause requires immediate investigation. This makes the control limits very important decision aids. The control limits provide information about the process behavior and have no intrinsic relationship to any specification targets or engineering tolerance. In practice, the process mean and hence the center line may not coincide with a specified value or target. If the quality characteristic because the process design simply cannot deliver the process characteristics at the desired level. Control charts limit specification limits or targets because of the tendency of those involved with the process to focus on performing the specification when in fact the least cost course of action is to keep process variation as low as possible. Attempting to make a process whose natural center is not the same as the target performed to target specification increases process variability and increases cost significantly and is the cause of much inefficiency in operation. Process compatibility studies to examine the relationship between the natural process limits and specifications. However, the process of control chart is to allow simple detection of events that the indicative of actual process change. This simple decision can be difficult where the process characteristics in continuously varying in control chart provide statistically objective criteria of change. When change is detected and considered good, its cause should be identified and possibly become the new way of working. Where the change is bad, then its cause should be identified and eliminated.
Audio Jungle.
Hello everyone, I am here today to discuss about scatter diagram. Scatter diagram for me is a graph in which the values of two variables are plotted along two axes, which means the x and y axis. The pattern of the resulting points revealing any correlation present. Scatter diagram procedure. Collect pairs of data where a relationship is suspected. Draw a graph with the independent variable on the horizontal axis and the dependent variable on the vertical axis. For each pair of data, put a dot or a symbol where the x-axis values intersects the y-axis value. If two dots fall together, put them side by side touching so that you can see both. Look at the pattern of point to see if a relationship is obvious. If the data clearly form a line or a curve, you may stop. The variables are correlated. You may wish to use regression or correlation analysis now. Otherwise, complete steps 4 through 7. Divide points on the graph into 4 quadrants. If there are x points on the graph, count x 1/2 points from bottom to top and draw a horizontal line. Count x 1/2 points from left to right and draw a vertical line. If number of points is odd, draw the line through the middle point. Count the point in each quadrant, do not count points on a line. Scatter diagram considerations. Here are some examples of situations in which you might use a scatter diagram. Variable A is the temperature of reaction after 15 minutes. Variable B, measure the color of the product. You suspect higher temperature makes the product darker. Plot temperature and color on a scatter diagram. Variable A is the number of employees trained on new software, and variable B is the number of calls to the computer helpline. You suspect that more training reduces the number of calls. Plot number of people trained versus number of calls. To test for autocorrelation of a measurement being monitored on a control chart, plot this pair of variables. Variable A is the measurement at a given time. Variable B is the same measurement but at the previous time. If the scatter diagram show correlation to another diagram where variable B is the measurement 2 times previously, keep increasing the separation between 2 times until the scatter diagram show no correlation. Even if the scatter diagram show a relationship, do not assume that one variable caused the other. Both may be influenced by a third variable. When the data are plotted, the more the diagram resembles a straight line, the stronger the relationship. If a line is not clear, statistics cue whether there is reasonable certainty a relationship exists. If the statistics say that no relationship exists, the pattern could have occurred by random chance. If the scatter diagram show no relationship between the variables, consider whether the diagram may be stratified. If the diagram show no relationship, consider whether the independent x-axis variable has been varied widely. Sometimes, a relationship is not apparent because the data don't cover a wide true range. A scatter plot or scatter graph is a type of mathematical diagram using Cartesian coordinates. Example, x-axis and the y-axis to display values for typically 2 variables for a set of data. If the points are color-coded, you can increase the number of displayed variables to 3. The data is displayed as a collection of points, each having the value of one variable, determining the position on the horizontal axis, and the value of the other variable, determining the position of the vertical axis. This kind of plot is also called a scatter chart, scattergram, scatter diagram, or scatter graph. One of the most powerful aspects of a scatter plot, however, it is the ability to show nonlinear relationships between variables. The ability to do this can be enhanced by adding a smooth line as a lowest. Furthermore, if the data are presented by a mixture model of simple relationships, these relationships will be visually evident as superimposed patterns. The scatter diagram is one of the best 7 basic tools of quality control. Scatter charts can be built in the form of bubble, marker, or at the line chart. That's all. Thank you!